The topic we'll be covering in this video is slope. Specifically, how to determine slope if you have a line segment that's actually on a graph, as you see over here on the right hand side. This is in your Intro to IM2 flipbook. This is section number 3, the top flap of section number 3. You should have seen slope also in previous math classes. In fact, when I go over some of the things for the flipbook, you should recognize many of those things. And we're going to be looking at slope in maybe a little different way than you've seen before, but a lot of this should be review. And you're going to need to remember these properties because we'll use slope throughout different parts of integrated math 2. So here we are on the top flap of section number 3. Go ahead and fill out the title, which is slope with a graph. Slope with the graph. We're going to have to also be able to figure out slope when all we have is the two endpoints, and we're going to need to figure out slope when all we have is an equation. So in this case, it's slope with the graph. Let's fill out this left section first, and then we'll talk about how to use that information to figure out slope. So slope is the rate of change. Now, I don't know if you've ever seen it described that way before, but slope is the rate of change. What we're talking about here is, take a look at this graph over on the right side. As I move from left to right, the y, that's the x value. As the x value is moving from left to right, the y value is changing by a certain amount. So by rate of change, it means is as we move this direction, we're changing at a certain constant speed. Every time I move, let's just show you this. Every time I move 1 unit over, our y value, take a look at where that's changing. Our y value is changing. Here it is, this much. And now I'm going to move 1 more unit over, and our y value is changing this much. See our y value? And that is called the rate of change. So I want you to start thinking about slope in that way. Okay, let me erase that stuff. You guys probably hear my phone ringing in the background, but I'm of course going to ignore that. Okay, so let's define it. Let's write it a couple different ways, and I'll go over these possible ways of writing out slope mathematically. Slope is, first of all, it's how much did we change on the y-axis over how much did we change on the x-axis. Remember our subunits? That's going to be just like I drew on our graph. How much did y change with a specific change in x? So the change in y over the change in x. Most students make the most common mistake on this is they put x on top, the change in x on top, and the change in y on bottom. And that is not correct. I know it seems confusing, but in this case the y value change goes on top and the x value change goes on bottom. We can also write this as triangle y over triangle x. Now, don't be fooled. This triangle in this case does not mean triangle. It's actually a mathematical abbreviation, and it basically means change. And we're going to label that in a moment. So change in y, change in the y value over the change in the x value. We could also write something very familiar, rise over run. How much did we go up and down? There's our rise. Over that amount of time or that amount of space that we did the change in rise or the distance, how much did we change left to right, or how much did we change our run? And then we can also write it one more way here. We could also just use arrows. How much did we change up and down over how much did we change left to right? By the way, this rise over run, a common way to think about this is stairs. If you know anything about contracting or heard contracting words, I've had to deal with this before. If you have a set of stairs, and I'll just draw a side view of stairs. Whoops, all of a sudden my cursor decided to stop working here. You got stairs. The rise is how high the stairs are. And the run is how long the stairs are. And there's rules about how high stairs can be and what's the minimum run. So that's one of the places where we actually use those words, rise over run. Okay, next one, let's write in here. I want you to just remember this. Positive slope means that the line is increasing over x values. As x gets bigger, the line or the y value increases. And I'm going to draw this as basically like an arrow going this way. So if you see a graph where the line is facing diagonal like this, that's a positive slope. As x goes up, y goes up. X goes up, y goes up. Negative slope means decreasing. And this actual graph right here is showing you a negative slope. That means as x goes up, y actually goes down. So write this arrow so you remember decreasing is an arrow that's pointing down from left to right. Now class, I don't know how many times I see students, they'll figure out the slope of this line and they'll tell me it's positive. Because they do the math and they mess up their negative sign somehow and they write a positive answer and they go, "Oop, that looks good," and they just move along. Please, when you're figuring out slope, always look at the line before you continue. If you ended up with a positive slope on this one, you absolutely know you made a mistake because positive slope is going to point this direction. Negative slope is going to point the direction you see here. This must be a negative slope. Let's go ahead and figure out this problem right now. Let's do one example. So I'm going to write down a couple things so we maybe get it stuck in your brain. Slope is equal to, we can write this as the change in y over the change in x, or what you are more used to seeing, and that is how much did the line rise for a particular amount of run, so rise over run. Let's take a look at how we do that. Well, I know that point A is on my line, and I know point B is on my line. Now, you got to be careful. It looks like right here, maybe the line is touching the grid, but I don't think so. It's just far enough off. I don't want to take a chance. I know that A is on our line, and I know that B is on our line. So let's go ahead and do rise and run. So I'm going to go ahead and draw a line. Let's just make a right triangle. Oops. Let's use our line tool for this. I'm going to draw a straight line all the way down to where I get to where B is at. And let's do a different color here on this one. I'll try this again. Let me get a line. There we go. Let's do different colors so we see this. Alright. So now we've made a right triangle, and now we should be able to pretty easily figure out what our rise and run is. Let's find out what this distance is. 1, 2, 3, 4, 5, 6, 7. And this distance is 1, 2, 3, 4, 5. Alright, so from A to B, we went 7 units down and 5 units to the right. Now remember, on the x-axis, this direction is positive, this direction is negative, and on the y-axis, this direction is positive and this direction is negative. So from A to B, think about it. Did we go down 7 units or up 7 units? You can see we're traveling down the y-axis, so this is actually -7. The rise is actually -7. Alright, let's take a look at the run. The run, once we get down to here, our run is traveling to the right. That's positive movement on the x-axis. That means it's +5. Oh, I'm going to write that in blue so it matches with our leg of our triangle. So our rise over run in this case is -7 over +5. -7 over +5, or -7/5. Now, some students say, well, Mr. Z, what if I drew my lines like this? What if I drew, instead of going down and over, I started from B and I went, let's pick a different color here, and I went up instead. Get rid of that mark. And I went up instead, and then I went over this way. Well, let's take a look at what would have happened. You would have had a rise of positive 7. You would have had a rise of positive 7, and then you would have had a run. Look, we're going to the left on the x-axis. We have a negative 5. So it's 7 over negative 5. Now look at the difference between these two. One student may have gotten negative 7 over 5, and one student may have gotten positive 7 over negative 5. The cool part is, that's the exact same answer. If you plug this into your calculator, negative 7 divided by 5, and your partner plugs in 7 divided by negative 5, it's the exact same answer. So it doesn't matter whether you went down and across this way or up and across this way. You get the same answer. In fact, another way to write this answer is you could have written negative 7 over 5. You can take the negative sign and put it out front. Now you can decide, do I want to put the negative with a 7 or the negative with the 5? It makes no difference. Negative 7/5 is going to be exactly the same. If you put this in your calculator, negative and then parentheses, 7 divided by 5, close parentheses, you'll get the same answer as 7 divided by negative 5 or negative 7 divided by 5. The important part is this slope is negative. This slope is negative. This slope is negative. And we clearly see on this diagram, this is a line that is decreasing. As x goes up, y goes down, and that means we have a negative slope. So all of these answers are negative slope. So every one of them is a correct answer.